Assalamualaikum and hello to everyone. My name is Nurul Fazila binti Haji Muhammad Zan. Today I will present my study entitled Indoor Hydroponic Cultivation System with IoT. Before we start, let's take a look at the contents of my presentation. First, we go to the introduction. The second one, we go to the problem statement. The third one is objectives. Then, material and methods, results and discussion, conclusion, and the last one, references. Let's start with the introduction. Hydroponics, often known as aquaculture or tank farming, developed as a method of systematically examining plant nutrition principles. Plants cultivated hydroponically may have no solid substance beneath them at all. Instead, their roots are frequently suspended in water with a nutrient-rich mix. The major advantage of hydroponics is the cost saving resulting from lower labor costs, as it is generally done in enclosed spaces with automated irrigation and fertilizer. Most hydroponic systems that use automatic control system are usually used for farm areas or for large-scale cultivation projects. However, this hydroponic planting system has many deficiencies in many ways if the system is to be built under the roof. Next, we go on to the problem statement for the project. Automatic control systems are less commonly used in small-scale hydroponic cultivation such as at home. Existing hydroponic planting systems usually operated for outdoor use. Users do not know if the plant is getting enough nutrients. Consumers also don't know if the plants are getting enough lighting or not. Therefore, the proposed technique was created to simplify and improve the hydroponic planting system for indoor or outdoor use. The objectives of this project are: the first one, to convert usual hydroponic system to automated and manual system and also can control it by smartphone. The second one, to control volume of water inside the trough using water level sensor that connected to Arduino Mega. And the last one, to control the LED lamp, either the plants need it or not. This is the overall block diagram of the indoor hydroponic cultivation using IoT. The whole system is controlled using the Arduino microcontroller as the heart of the system. A light sensor, water level sensor, and pH sensor will be the main input for the system, and there are two outputs for the system using the LED lamp and water pump motor. The light sensor will respond as a light detection source to allow the plant to get a sufficient rate of light. The water level sensor operates to ensure that the total volume of water supplied to the plants is sufficient. The pH sensor is intended to determine the pH level in the water. The whole process can be observed in the Android smartphone application that is connected wirelessly using Bluetooth technology. This flowchart showing the whole process for the system. Based on the flowchart, the Arduino microcontroller system will process the data to know the status of all available sensors. It will then read the water level status and will activate the water pump if needed. Arduino will read the status of the light sensor to find out the current light conditions in the planting area. Temperature concentration will also be assessed using a pH sensor. All these conditions will be reported to the user using the smartphone via the Bluetooth module connected to the Arduino. Hardware development for this project are using Arduino Mega 2560 microcontroller, HC05 Bluetooth module, pH sensor electrode, the water pump, liquid water level sensor, and the light sensor module. Software development for this project are using Arduino Integrated Development Environment to write and compile the coding onto our primary board. This is the whole circuit board for the system. The main circuit using the Arduino has been built and installed. Water pump and LED lamp is connected to the SPDT 5V relay module, and then SPDT 5V relay module, light sensor, water level sensor, Bluetooth module HC05 and pH sensor is connected to the Arduino. All the circuit is placed inside a controller box. These are the arrangement for the system. The UPVC tube must be properly sized, and the distance between the holes at the pipes must be the same. The end of the tube that has been properly sized had to be closed and punctured to make way for the water to pass through it. The design for this tube coming from an S shape. The black tube is connected to the PVC tube, which acts as a conduit for the water to flow through the trough. The next step is making the stands for the hydroponic project from the iron elbow holes. This is the whole hydroponic system configuration setup. The light sensor is placed at the top of the hydroponic rack to sense for the sunlight or any light level inside a house. The LED lights in high places will provide even lighting to the entire hydroponic plant. A water level sensor is installed in the UPVC pipe to measure the water level in the pipe. The water pump is placed next to the water tank to facilitate the process of pumping water into the UPVC pipe. This project is portable created, so users can easily change the position of the project anywhere they want. Tests are performed on the light sensor of the hydroponic system to see the effectiveness of light detection and lighting when the hydroponic system is placed outdoors and also indoors. On table 5, it can be seen that the lights will only start to light up when the atmosphere is getting dark at night. From table 6, it can be seen that in the situation in the house with relatively low lighting will cause the duration of LED lights is longer in the morning and at night. This is the user display on mobile phone. On the user display, there is space for the display of pH content in water and water level. Figure A shows the operation for automatic or manual control, and Figure B shows the control display for the water pump manually and also the LED light control manually. For the conclusion, this study has succeeded in establishing an automated system for indoor hydroponic cultivation system with IoT, based on the research that has been done into monitoring, controlling water circulation in hydroponic and LED lighting system for indoor usage. The combination of a lighting system and an IoT system that uses Bluetooth will undoubtedly increase the use of an automated hydroponic system for indoor use. That's all from me. Thank you.